Hello everyone, welcome to our operating systems project presentation. I am Preeti Kondabiti. What you're seeing is the real-time dashboard, a real-time process monitoring dashboard that we have built entirely in C++ with native Windows GUI. The main idea behind this project is from a very simple question. When we open the Windows Task Manager, what is actually happening under the hood? How does the operating system keep track of every running process with CPU usage, memory consumption, and state, all in real time? We wanted to build something that answers that question, not just theoretically, but as fully working application. So let's dive right in. This is the real-time processing dashboard that we have made.
Thanks. So here's the dashboard live and running on our mission. Let me walk you through what you're seeing. At the top, you have two progress bars, one for CPU usage and one for memory consumption. These update automatically every single second without you having to click anything. That's our auto refresh mechanism working in the background. Below that is a process table. Each row represents one active process on this mission. You can see columns for PID, the process ID, and the name, what is the process is called, and the state, whether it's running or waiting, and CPU percentage, how much processing power it's consuming, and memory usage in kilobytes or megabytes. The list is live, which how it refreshes. No new processes appears, only old ones disappear all automatically. Now this is not just a read-only viewer. We have built process management directly into the graphic user interface. Let me show you that. So at the bottom of the window there is a PID text box. Suppose for example I'll type 14732. So let's say this background process is here, and now I have three actions to take. First, to kill. If I click kill, it automatically gets terminated. The dashboard shows a confirmation dialog first, so you don't accidentally kill something important. uh, Next, there are priority control. I can set any process to low, normal, or high priority just by clicking these buttons. This directly maps to the OS level priority scheduling.
And this is where things get really interesting from an OS perspective. When we set a process priority, we are not just changing a label, we are telling the CPU scheduler to allocate more or fewer time slices to that process. In Windows, this uses set priority class API call under the hood. High priority processes get scheduled more frequently, which is exactly the kind of concept we studied in our CPU scheduling module. Round robin priority scheduling, all of that is happening at the OS level when we click those buttons. Let me talk about how we actually built this. This entire project is written in C++, which gave us the direct access to Windows system APIs, specifically Windows API, for process enumeration, the Windows 32 GUI framework for the interface. For build system, we used CMake, which made it easy to compile the project cleanly. You can just run two commands. That is, here I will give the two commands, and this after this you get a ready to run .exe file. Like if I enter this here, the entire project is running and we can see the dashboard, and you get a ready to run exe file. One of the key technical challenges we solved was threading. The process sampling, reading CPU and memory data happens on a background thread. One of the key technical challenges we solved was threading. The process sampling, reading CPU and memory data happens on a background thread, completely separate from the UI thread. This is critical because if we sampled processes on the main thread, the UI would freeze every second. We used double buffered list rendering to make the updates smooth and flicker free. The dashboard is also resize aware. If you stretch the window, the layout adjusts automatically. That required careful handling of Windows WM size messages.
To some of the OS concepts we have applied in this project are the process management. We enumerate all active processes using system calls and display their states, connecting directly to what we have learned about the process lifecycle. The second one is CPU scheduling. The priority control feature ties directly into primitive scheduling and how the operating system decides which process to run next. The third one is memory management. We display real-time memory consumption per process, reflecting the OS's memory allocation for each. The fourth one is concurrency. Our background refresh thread runs independently of the GUI, which is practical implementation of multi-threading. This project taught us that operating systems aren't just a theory, they are the foundation of every tool we use. Thank you for watching our RTP dashboard project. This was built as a part of our operating systems coursework, and we hope it gave you a clear picture of how the real-time process monitoring works at system levels. Thank you.